my name is Sydney Riemer, and in my project for Hack the Bay, I studied a classification of rock types by their reactivity with water in a portion of the Chesapeake Bay watershed to see if they can be used as predictors of pollution loads into the bay. The problem is that the Chesapeake Bay is being polluted by human activity on land, such as through the use of fertilizer, which enters the bay through streams and rivers. This pollution causes problems such as oxygen minimum zones and harmful algal blooms, which are a threat to marine life. Land cover and land use are important for considering how activity in the watershed is affecting the health of the bay. However, near-surface bedrock geology is also important. Certain rock types contain minerals and matter that are more reactive towards water. In a study by the United States Geological Survey, Pepper and colleagues devised a high-resolution map in 2001 of 2 watershed states, Maryland and Virginia, comprised of 30 different litho-geochemical rock units. The map is reproduced here on the right, with the black squares representing CVP and CMC water quality sampling sites. This map emphasizes the reactivity of certain rocks with water, unlike traditional geologic maps that map the rocks based on age and spatial relationships. Examples of some of the water-rock reactions are that rock types rich in carbon create a low-oxygen environment, where nitrate can be removed from waters through a microbiological process called denitrification. Carbonate rocks can neutralize acidic water, and carbonate rocks and permeable, well-drained sediments create oxic conditions that are not conducive to denitrification, the microbial process described above. All of the analysis for this project was done using the Python programming language and the geospatial analysis package GeoPandas, which I used to spatially join the water quality and geology data. I also used the Pandas, SciPy, and Matplotlib packages. First, I performed an exploratory data analysis by making a box plot of the nitrate concentration of the different rock types to get a general overview of how the data is distributed. Because the main goal is to see if geology can be used as a predictor of water quality, I wanted to see if there's a difference in the nitrate concentrations of the different rock types. Here, looking at the 17 different lithogeochemical units in both Maryland and Virginia, there does seem to be a difference in the units. This exploratory data analysis warrants a further analysis of the data, which I did by performing statistical hypothesis tests. I used the Mann-Whitney U-test, which gives a p-value and doesn't assume a certain distribution of the data and is also robust to outliers. Using a significance level of 0.05, I can see that with the lithogeochemical units, the majority have a significant difference in nitrate loads. The units that aren't different might both be non-reactive towards water or have other similar properties. Further investigation is needed to determine the exact cause. In the plot here, the darker blue colors represents significantly different nitrate loads. The difference in nitrate concentrations for the majority of the lithogeochemical units are statistically significant, as we can see here in the heat map. This indicates that a classification of rock types based on reactivity with water can be used as a predictor of pollution loads in the Chesapeake Bay watershed. Rock types can be included in machine learning models to aid in prediction of pollution. Additionally, rock types can be used by land managers and policymakers to decide where to build farms, towns, etc. This can be accomplished by looking at a geological map. As this was only a partial study, there is much more work to be done. Future work will clean up the data more so that temporal changes are taken into account. Utilize land use and land cover datasets to deconvolve other possible factors affecting water quality in different lithogeochemical regions. Determine how rock type affects other water quality indicators, such as phosphate and pH. Understand why certain rock types do not have significantly different nitrate loads. Incorporate superficial rock types and groundwater data into the analyses. And incorporate lithogeochemical rock types into predictive models of Chesapeake Bay water quality. Thank you for listening to my presentation. I hope you learned a lot, and I hope that rock types can be used in further analyses of water quality in the Chesapeake Bay watershed.